All right, here we are at level 3. This is number 8. This question is, you just have to get your head around the wording of it. Be careful not to read too much into it. Okay, so what you have is a swarm of pellets. So essentially, all we're doing is we're taking the kinetic energy of pellets in orbit, and we're comparing that to the kinetic energy of a rifle. So compared to, remember, compared to is like a fraction, the EK of a rifle. That's really all we're doing. The question sort of goes on a bit wordy and makes it sound like we have to calculate something with the satellite and all of this, right? Essentially, basically, if the satellite is moving this way and the pellets are moving this way, then what that means is the pellets are going to hit the satellite, but it's going to be very fast. And we want to basically see these pellets. How do they compare to a bullet, right? And this will give you an interesting answer that makes you realize that when you're up here in the space shuttle going around the Earth, a piece of dust orbiting in the opposite direction can actually, be detrimental to your entire mission. Little tiny rocks can hit the space shuttle at tremendously high speeds, as we'll see. So this is what we're really after. We just want to compare the kinetic energy of the pellet to that of a modern rifle. Just read the last sentence and that's what you're after. Okay, so let's figure out how we're going to do that. Well, the EK for a pellet is 1/2 mv squared. And so in order to do that, we know the mass, but we need to know something about the V. So to get the V, we have to consider the pellet being in orbit. Now remember, if you're in orbit, okay, here's the Earth. If you're up here and you're moving in an orbit around the Earth, you have two things. You have to be moving. You're not just sitting still. So you have EK and you have EG, right, in this position up here as you move. And the EG, in this case, cannot be mgh. It has to be the negative gm1 m2 over r because we are orbiting far above the Earth. So what you're going to do is you're going to first calculate the orbital speed that would be needed to maintain that orbit. And to do that, you're going to have to figure out, I'm thinking you're going to have to figure out, well, actually, no, you should be able to just jump right in and figure out what the orbital speed of that would be. I think you'll have all of the variables that you need to do that. Be careful when you do your orbital speed. Make sure you use the right equation because the escape velocity is very similar, right? One has a 2 in it and one doesn't. So you do a plug and play. You get your orbital speed that you would need for this particular pellet or group of pellets. And once you have the orbital speed, you can use it here to figure out their kinetic energy. And that's really all there is to it. You have 1/2 mv squared, and you're trying to figure out that's the pellet speed. I'll put a P there, and then you're just going to compare that. So that's going to give you a nice happy number of kinetic energy, and then you're going to do the same thing for the bullet from the rifle. That's going to give you another happy number of kinetic energy, and then you're going to compare the two. Compared to, and simply that. So this question is really much simpler than it looks. It sounds crazy. You don't even have to actually figure out any of the EG that's going on, because think about it. If you're here at this point going this way and the bullet, basically your orbital speed already takes into account that EG because it comes from the same equation, right? You have the G and the M and the R